Hello students, today we are covering lesson 4.3 on solving inequalities using multiplication and division. Follow along with me on page 140 in your textbook. Our first key idea is on multiplication and division properties of inequality. This is case number 1. I would like you to copy this down, so pause the video to write it down. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So for example, if you have negative 4 is less than 6, if you multiply both sides by 2, negative 8 is still less than 12. Or for example, with division, 4 is greater than negative 6. If you divide both sides by 2, 2 is still greater than negative 3. So if A is less than B and C is a positive integer, then A times C is still less than B times C. And A divided by C is less than B divided by C. Or if A is greater than B and C is positive, then A times C is greater than B times C. And A divided by C is greater than B divided by C. So these properties are also true when you have less than or equal to and greater than or equal to. So take a moment and copy this down. Okay, example 1, we're going to solve an inequality using multiplication. This example is found on page 140 in your textbook. So to solve, we need to isolate our variable x. We have x divided by 5 is less than or equal to negative 3. So to solve for x, the first thing I need to do is isolate my variable. I'm going to rewrite it over here. X divided by 5 is less than or equal to negative 3. In order to get x alone, to undo division is to multiply both sides by 5. 5x divided by 5 cancels out to 1x, so I just simply write it as x is less than or equal to negative 15. Now when I graph it on my number line, let's say here's a negative 15. X is greater than or less than or equal, so it does have a closed dot because this symbol here means it will be closed since it does equal that number. And if x is less, we shade it to the left on the number line, not above the line or below the line, but on the line. And there we have graphed it. Now I would like you to solve these inequalities, and then I would like you to graph the solution. Remember, to isolate the variable, you have to multiply if it's being divided. So keep that in mind. All right, example 2. Solving an inequality, this time we're using division. 6x is greater than negative 18. I'm going to rewrite this over here. To isolate x, I divide both sides by 6. 6 divided by 6 is 1. 1x, or x, is greater than negative 3. Now I graph it on the number line. I'm going to say here's negative 3, negative 2, negative 1, 0. You can number your number line however you like. And x is going to be greater than negative 3, but it does not equal negative 3. This symbol means you will have an open circle. So I'm going to use open circle at negative 3. If x is greater, you shade it to the right on the number line. Remember, don't shade above or below the line. It has to be on the line. Now I'd like you to try 4 through 6 on your own. Graph the solution on a number line. Now our second key idea for multiplication and division properties of inequality, this is the second case, and it's a little bit different. When you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed in order for the inequality to remain true. So if you have negative 4 is less than 6, if you multiply both sides by negative 2, multiplying by a negative means you have to do the opposite of what the symbol says. So if this says greater than, you must switch the symbol from what it started it at less than. So notice how the symbol changes from negative 4 is less than 6. Now it's greater than because we multiplied by a negative. And listen to this, 8 is greater than negative 12. That is true. If you have 4 is greater than negative 6, but you divide by a negative 2, you have to switch the symbol so that negative 2 is less than 3. So in algebra, if A is less than B and C is negative, then A times C is greater. Notice the sign switched from less than to greater. It's greater than B times C. And A over C is greater than B over C. Same is true if you have A is greater than B and C is negative. If you multiply both sides by a negative, you have to switch the symbol. So A times C is less than B times C. Same with division. And these properties are also true for less than or equal to and greater than or equal to. Pause the video and copy down the key idea. Example 3 is solving an inequality using multiplication with a negative coefficient. So here we have negative 3 over 2 times n. Our coefficient is the negative 3 over 2. And this is less than or equal to 6. So I'm going to rewrite it over here. Now to isolate n, I need to get rid of negative 3 over 2. So I need to multiply by the reciprocal. So I'm going to multiply both sides by negative 2/3. Whenever you multiply by a negative, you must reverse this symbol. So instead of less than or equal to, now it's greater than or equal to. So that cancels out, and you get n is greater than or equal to, and 6 over 1, this can cross simplify. 2 times negative 2 is negative 4. So n is greater than or equal to negative 4. Now we need to graph it. So when we graph, I'm going to number my number line here. There's negative 4. It is greater than or equal to, so it is a closed circle. If n is greater, you shade it to the right. Okay. So the only thing you need to remember is multiplying or dividing by a negative coefficient means you have to switch the symbol to reverse to the opposite of what it says. I'd like you to try 7 through 10 on your own. Remember to graph the solution on a number line when you're done. Example 4 is solving an inequality using division with negative coefficients. So now we have negative 3z is greater than negative 4.5. To solve this, I divide both sides by negative 3. Notice when you divide or multiply by a negative, you must reverse the symbol. So instead of z is greater than, now z is less than. Negative 4.5 divided by negative 3 makes positive number. And when you divide it out, you get z is less than 1.5. So now I'm going to graph. Here's my graph. Here's 0. There's 1. There's 2. 1.5 is here. So if z is less, I'm going to shade it to the left on the number line. Okay. Notice my open circle because z does not equal 1.5. It is less than 1.5. Now I'd like you to try 11 through 14 on your own. Graph the solution on a number line on your piece of paper. For your exit ticket, I would like you to solve numbers 15 and 16 and graph them. Notice if you have a negative that you are multiplying or dividing by, you must switch the symbol only if it's a negative. If this, like in number 16, if it's positive coefficient, you keep the symbol the same. Okay? I hope you have a great day, and I'll see you in class tomorrow. Bye-bye.